The topic I am going to take up today is integration by parts. Integration by parts is a limited product rule. Unlike in differentiation, where we have a product rule which can be applied on product of any two functions, here in integration we have a very limited product rule, integration by parts. This can be used only in a particular type of situations. This result is not very helpful in general. This can be applied only on a particular type of functions, which we will discuss now. First is, what is the rule? What is integration by parts? Now, rule is integral fx gx dx is equal to fx integral gx dx minus integral of differentiation of fx into integral of gx dx whole dx. Fx integral of gx dx minus integral of differentiation of fx into integral of gx whole into dx. What we will do is, we will first evaluate integral gx, multiply it with differentiation of fx, and then integrate this whole with respect to x. Now in practical questions, we remember this rule as integral of first function into second function dx is equal to first function integral of second function dx minus integral of d by dx of first function into integral of second function dx whole into dx. First function integral of second minus integral of differentiation of first into integral of second dx. What we note here is integral of second function is involved in both the terms. Integral of second function, integral of second function. Here we have first function and its differentiation. Integration of first function is not involved. Integration of second function is involved in both the terms. In first term we have first term, and in second term we have differentiation of first function. First function, differentiation of first function. Integral of second, integral of second. So we will remember this rule as integral of product of first and second function dx is first function integral of second minus integral of differentiation of first into integral of second with respect to dx. Now, what is the rule to choose first and second functions? Now, rule to choose first function is choose polynomial as first function. We will always choose polynomial as first function, with the exception whenever log is involved or inverse trigonometrical functions are involved, we will take these functions as first function. Even if polynomial is involved, we will choose log or inverse trigonometrical functions as first functions. So rule to choose first function is choose polynomial as first function. Exceptional cases are log or inverse trigonometrical function. If log or inverse trigonometrical functions are involved, we will choose these functions as first functions. Or you can remember this in this form also. Elate. I stands for inverse trigonometrical functions. First preference will be given to inverse trigonometrical functions. L is log functions. A is algebraic functions. T is trigonometrical functions. And E is exponential functions. Order of preference will be I, L, A, T, E, elate. But I think this rule is easy to apply and is quicker. So we will always remember only two things. Choose polynomial as first function, with exceptional cases log and inverse trigonometrical functions. Simple. So I will use this. If you want to use this, you can use this also. Now we take up some questions. Evaluate the following integrals. First is integral x square sin x dx. Now what we do is we choose this as first function and this as second function and apply integration by parts. Now first function x square, first function into integral of second. Integral of second is integration of sine is minus cos x. First function into integration of second minus integration of differentiation of first. Differentiation of first is 2x into integration of second. Integration of second is minus cos x dx. With some practice, we will apply integration by parts directly. First function into integral. We will write the integral of this function directly. First function integral of second minus integral of differentiation of this. We will write the differentiation of this directly. Differentiation of first into integration of second. And this can be written as minus x square cos x minus plus 2 integral x cos x dx. We will use integration by parts once again. Regard this as first function and this as second. This is equal to minus x square cos x plus 2 into first function integration of second. Integration of cos is sin x minus integration of differentiation of first. Differentiation of x is 1 into integral of second. Integration of cos x is sin x dx. This is equal to minus x square cos x plus, open this bracket, this will be 2x sin x minus. Now integration of sin x is minus cos x. So minus minus is plus cos of x, and we have 2 from here. So this will be 2 cos x plus constant of integration. So this is the answer. Clear? So what we do is we choose this as first function and this as second. First function integral of second minus integral of differentiation of first into integral of second. We write the integral directly and differentiation directly. First function integral of second minus integral of differentiation of first into integral of second. We get this. Again apply integration by parts. First function integral of second minus integral of differentiation of first into integration of second, and integral of this is cos x. So this is solved. Now next we take integral of sine inverse x dx. Integral of sine inverse x dx. So what we do here is now sine inverse x is an exceptional case, inverse trigonometrical function. So what we do is we write this as sine inverse x into take 1 as second function. This is very important. Take this as first function and 1 will be taken as a second function. If it is say x sine inverse x, then we will take sine inverse x as first function and x as a second. But here we have only 1, sine inverse x into 1. So we will take 1 as a second function and integrate by parts. So this will be equal to first function, that is sine inverse x first function into integral of second. Integration of 1 is x minus integral of differentiation of first. Differentiation of this is 1 by under the root 1 minus x square into integration of second function. Now this can be written as x sine inverse x minus integral of x over under the root 1 minus x square dx. Now differentiation of 1 minus x square is minus 2x. So what we do is we multiply this by minus 2 and divide by minus 2. So this will be plus 1 by 2. Minus is plus. Now this is a complete integral. We can write this as x sine inverse x plus 1 by 2 integral 1 minus x square to the power of minus half into 2x dx. And this is equal to x sine inverse x plus 1 by 2. Now this is fx to the power of n into f dash x. This is a complete integral. So integration will be fx to the power of n plus 1 over n plus 1. So integration will be 1 minus x square to the power of minus half plus 1 over minus half plus 1 plus c. And this can be written as x sine inverse x plus. Now this is half cancels and we get 1 minus x square to the power of half. So we have 1 minus x square to the power of half plus c. So this is the answer. Now we modify this question a bit. Suppose question is integral x sine inverse x dx. Now this is an exceptional case. We will take inverse trigonometrical function as a first function. So we can write this as sine inverse x into x dx and regard this as first function and this as second. So this is equal to first function sine inverse x into integral of second. Integral of second is x square by 2 minus integral of differentiation of first. Differentiation of sine inverse x is 1 over under the root 1 minus x square into integration of second. Integration of second function is x square by 2. So this is x square by 2 dx. So this can be written as sine inverse x into x square by 2 minus 1 by 2 integral x square over under the root 1 minus x square dx. Now in situations where we have quadratic over root quadratic, what we do is we express this quadratic in terms of the quadratic in the denominator. If it is under root 1 minus x square, we will express this in terms of this. If it is without under root, even then we will express this in terms of the quadratic in the denominator. So what we do is we will write this as x square sine inverse x by 2 minus, or we take minus inside, 1 by 2 integral under root 1 minus x square, and this minus I have taken inside. So this will be minus x square. Now we have to express this in terms of this. So what we do is we add 1 and subtract 1. So this is, now separate this into 2. So this will be x square sine inverse x by 2 plus 1 by 2 into. Now this cancels with this. We have integral of under the root 1 minus x square dx minus integral of, now this is this. Now with this we will have minus 1 over under root 1 minus x square dx, and this is equal to x square sine inverse x by 2 plus, now this can be written as 1 by 2 into integration of this. Integration of this is x into this by 2, x into 1 minus x square by 2. You can see the side sheet. X into this by 2 plus a square by 2. A square by 2 is 1 by 2 into integration of its reciprocal. Now integration of reciprocal of this is sine inverse x. So integration of this is x into this by 2 plus 1 by 2 into integration of reciprocal of this minus integration of this. Integration of this is sine inverse x. So we will have minus sine inverse x. Therefore this can be written as x square sine inverse x by 2 plus, open this bracket, we will have x under root 1 minus x square by 4 plus, now half minus 1 is minus half, so minus half into half is minus 1 by 4, so we will have minus 1 by 4 sine inverse x. So this is the answer. If we have x instead of 1, we will take x as second function, and in this case we will take 1 as a second function, and this will be solved like this. This can be solved. Now I take up the third part of this question, that is integral of log 1 plus x square dx. Now this is again an exceptional case, so we will write this as integral log of 1 plus x square into 1 dx. We will take this as a first function and 1 as a second function, as we did in case of sine inverse x. Sine inverse x as first function and 1 as second. So here we will take log 1 plus x square as first function and 1 as second function. So this will be regarded as first function, this will be regarded as a second function. So this is equal to first function, that is log of 1 plus x square, first function into integration of second. Integration of second is x minus integral of differentiation of this. Differentiation of this is 1 over 1 plus x square into differentiation of inner function. Differentiation of inner function is 2x. So we will write 2x. Differentiation of this is this into integration of second. Integration of 1 is x dx. First function into integration of second minus integration of differentiation of this. Differentiation of this is 1 over 1 plus x square, and differentiation of inner function is 2x. So 2x over 1 plus x square into integral of second function, that is x dx. Now we solve this. This is x log 1 plus x square. X log 1 plus x square minus 2 is common, integral of x square over 1 plus x square dx. So as I explained you in the previous question, whenever we have quadratic over root quadratic or quadratic over quadratic, what we do is we express this quadratic in terms of this quadratic. So to express this quadratic in terms of this quadratic, what we do is we will add 1 plus x cube. This quadratic has been involved. Minus 1 plus 1 minus 1 and separate into 2. So this will be x log 1 plus x square minus 2 into. Now separate this. 1 plus x square over 1 plus x square will be 1 minus integral of 1 over 1 plus x square dx. Here it should be integral of 1 dx. So this is equal to x log 1 plus x square minus 2 into integral of 1 dx. So integral of 1 dx will be x minus integral of this. Integration of this is tan inverse x plus c. So this is the answer. Now we modify this question a bit. If the question is, say, integral x log 1 plus x square dx. What we will do is we will write this as log of 1 plus x square into x dx. This will be regarded as first function and this is second function, because this is an exceptional case, log and inverse trigonometrical function. So this can be written as first function, that is log of 1 plus x square into integral of second. Integration of second is x square by 2 minus integral of differentiation of this. Differentiation of this is 1 upon 1 plus x square into differentiation of inner function, that is 1 plus x square. Differentiation of 1 is 0 and differentiation of x square is 2x. So we will have 2x into integration of second. Integration of second is x square by 2. This 2 cancels with this and we will have log of 1 plus x square whole into x square by 2 minus integral of x cube by 1 plus x square dx. Whenever division is possible, carry out division. First step is whenever division is possible, carry out division. So what we do is we will divide x cube by 1 plus x square, which can be written as x square plus 1. We can write this as x square plus 1 and divide x cube by this. So this is x, so this will be x cube plus x minus 1. This cancels, we get minus x. So we can write this as x square by 2 log of 1 plus x square minus integral of, now x cube over 1 plus x square can be written as quotient plus remainder over denominator. Quotient is x plus remainder. Remainder is minus x. Remainder over denominator. Denominator is 1 plus x square dx. Now this can be written as x square by 2 log of 1 plus x square minus. Now integration of x is x square by 2 minus plus, this will be plus. I am closing the bracket here. So minus minus is plus. So this will be plus integral x over 1 plus x square dx. Now differential of this is 2x. So if I multiply this by 2 and divide by 2, then this will be a complete integral. This is a complete integral. We have f dash x over fx. So integration of this will be log of 1 plus x square. So we will write this as x square by 2 log of 1 plus x square minus x square by 2 plus 1 by 2, and integration of this will be f dash x over fx, which is log of fx. So this will be log of fx, that is 1 plus x square plus c. So this is the answer. So in this case we had x square. So we express this quadratic in terms of this quadratic, or we can also use this. Carry out division whenever possible. We can use this rule also. Carry out division whenever possible. So this can also be dealt as x square divided by x square plus 1. So 1, this will be x square plus 1. This is minus, this is minus. This cancels, minus 1. So we can write x square over 1 plus x square as quotient. Quotient is 1. Quotient plus remainder over denominator. Minus 1 over 1 plus x square. So we reach at this step. We can do it like this or carry out division whenever possible. Now we take up some more questions. First is integral log of x plus 2 over x plus 2 whole square dx. I will do this question in two different ways. First is I make this substitution. Put log of x plus 2 equal to t. So differentiate this. This will be 1 over x plus 2 dx is equal to dt. Differential of this is 1 over x plus 2, and differential of inner function is, differential of this is 1 and this is 0. So 1. So 1 over x plus 2 dx is dt. And this implies x plus 2 is equal to e to the power of t. Log x plus 2 is t. This implies x plus 2 is e to the power of t. So we can write this integral as I is equal to integral log x plus 2 is t. So we write this as t. T into. Now this is 1 over x plus 2 into x plus 2. So 1 x plus 2 goes in the simplification. Dx over x plus 2 is dt. So 1 power becomes dt. And 1 x plus 2 is left. And x plus 2 is e to the power of t. So this is t over e to the power of t dt. And this is equal to integral t into e to the power of minus t dt. Now we use integration by parts. Integration by parts. So this will be the first function, this is the second function, because this is not an exceptional case. So we will do this as first function into integration of second. Integration of e to the power of minus t is e to the power of minus t over coefficient of a, that is minus 1. Coefficient of x, we must divide by the coefficient of x, because a rule for x is being used for ax plus d. So we must divide with the coefficient of x, that is minus 1. Minus integral of differentiation of first. Differentiation of t is 1 into integration of this. This is e to the power of minus t over minus 1 dt. And this is equal to minus t e to the power of minus t minus minus plus and e to the power of minus t. Integration of e to the power of minus t is e to the power of minus t, and quotient of t is not 1. So we must divide it by this plus c. Now we must change this into the original variable. So we can write t as log of x plus 2. So this will be minus log of x plus 2 into e to the power of t is x plus 2. So e to the power of minus t will be 1 over x plus 2. E to the power of minus t will be x plus 2 to the power of minus 1. That is 1 over x plus 2. So this will be 1 over x plus 2. E to the power of minus t can be written as 1 over x plus 2 plus this term. Now this is minus. So minus e to the power of minus t. E to the power of minus t will be this to the power of minus 1. So this will be 1 over x plus 2 plus c. So this is the answer. Now we do this question in an alternative way. What we do is I is equal to integral, we write this function as log of x plus 2 into x plus 2 to the power of minus 2 dx. Now this is an exceptional case. We will write this as first function and this as a second function. So this will be equal to first function log of x plus 2 first function into integration of this. Integration of this will be x plus 2 to the power of minus 2 plus 1, that is x plus 2 to the power of minus 2 plus 1 is minus 1 divided by minus 2 plus 1 is minus 1. Minus integral of differentiation of first. Differentiation of this is 1 over x plus 2. 1 over x plus 2 into integration of this. So integration of this is x plus 2 to the power of minus 1 over minus 1 dx. And this can be written as this is equal to, this is minus 1 over x plus 2. So this will be minus log x plus 2 divided by x plus 2. This is minus 1 over x plus 2. So we can write this as minus log x plus 2 divided by x plus 2. And this is minus minus is plus. So this will be plus integral x plus 2 to the power of minus 2. Minus minus plus, and this will can be written as x plus 2 to the power of minus 2 dx. And we can write this as minus log of x plus 2 divided by x plus 2 plus, now this is a linear, so we can write this as x plus 2 to the power of minus 2 plus 1 over minus 2 plus 1. So integration is completed. We will write this as minus log of x plus 2 over x plus 2, and this will be minus 1, and this is minus, so this is minus 1 over x plus 2 plus constant of integration. Now this answer is same as this. So we can do this question either in this way or this way. Make this substitution and change this into e to the power of t and integration by parts, or directly do the integration by parts. Now we take up the second part, that is sine inverse x over 1 minus x square to the power of 3 by 2 integral of sine inverse x over 1 minus x square to the power of 3 by 2 dx. So what we do in this case is we simplify this question first. What we do is sine inverse x equal to t, because we do not have many formulae for sine inverse x. So I will first eliminate sine inverse x. So what we do is we put sine inverse x equal to t. So this will be x is equal to sine t, and this implies differentiate this. This will be 1 over under the root 1 minus x square dx is equal to dt, and this also implies x is sine t. So we can write this as, let this be equal to I, or we can write this function as sine inverse x over, now separate this. So this will be 1 minus x square into under the root 1 minus x square dx. 1 minus x square to the power of 3 by 2 is 1 minus x square into 1 minus x square under the root. 1 plus half is 3 by 2. So we can simplify this as integral sine inverse x is t over, now dx over this is dt. Now this is dt. So we are writing t dt, and 1 minus x square, 1 minus x square can be written as 1 minus x, x is sine, so sine square t. 1 minus x square can be written as 1 minus sine square t. So this is equal to integral t over 1 minus sine square. 1 minus sine square is cos square t. Change this in terms of a single term. It is always beneficial to change the denominator into a single term. So this can be written as integral t into 1 over cos is secant square t. So this can be written as first function and this as second function. Now we will do integration by parts. So this is equal to first function into integral of this. Integral of secant square t is tangent t minus integration of differentiation of first is 1 into integration of this is tangent t dt, and this is equal to t into tangent t minus, now integration of tangent t. Integration of tangent t is log of secant t plus c. Integration of tangent x is log mod secant x. So this can be written as, now we will change this in terms of the original variable. So t is sine inverse x. This is sine inverse x. Now tangent t, we know sine of t is 1 by x. Let this angle be t. So sine is perpendicular over hypotenuse. So this will be x and this will be 1. Now sine of t will be x by 1. And by Pythagoras theorem, this side will be 1 minus x square. Now tangent of t will be this upon this, perpendicular over this. So x over under root 1 minus x square. This is an easy method to express tangent t in terms of sine t. Make a triangle and instead of remembering the formulae, we can use this method. This will be x over under root 1 minus x square minus log of secant t. Now secant t will be 1 over cos t. Cos is this upon this. So secant will be 1 upon under root 1 minus x square. 1 over under root 1 minus x square plus c. This can be written as x sine inverse x over under the root 1 minus x square. Minus, this is 1 minus x square to the power of minus half. Now we know log m to the power of n is n log m. This power can be taken out. So this power is minus half. So minus half can be taken out. This will be plus 1 by 2 log of 1 minus x square plus c. This can be written as log of 1 minus x square to the power of minus half, and using this rule minus half will be taken out. So this is the answer. Now we take up the third part of the question, that is integral x minus sin x over 1 minus cos x dx. Now what we note in this question is we have 1 minus cos x in the denominator. Most of the questions where we are able to change the denominator into a single term is always helpful. So if we write 1 minus cos x into a single term, that is we write 1 minus cos x as 2 sin square x by 2, then this will change into a single term and we will be able to separate this question into two simple questions. First will be x over sin square x by 2 and second will be this upon sin square x by 2. Here we will change sin x into 2 sin x by 2 and cos x by 2. 2 sin x by 2 cos x by 2. So what we do is we change this into a single term. That is we write this as x minus sin x over. This is 2 sin square x by 2. Because we know 1 minus cos 2 theta is 2 sin square theta by 2. So we can write this integral as integral x minus 2 sin x by 2 cos x by 2. We are changing this question in terms of sin x by 2 and cos x by 2. So this is 2 sin square x by 2. Now separate this into two simple questions. So first is integral x and take this 2 common. This will be 1 by 2. 1 by 2 x into sin square x by 2. Now 1 over sin square x by 2 can be written as cosecant square x by 2. This can be written as cosecant square x by 2 dx. This is the first term. Minus integral, second term will be 2 will cancel with 2 and we will be left with sin will cancel with this sign. So we will be left with cos x by 2 over sin x by 2. That is cotangent x by 2. So this can be written as cotangent of x by 2 dx. 1 by 2 into, now we do integration of parts. First function is x into integral of this. Integration of cosecant square x is minus cotangent x. So minus cotangent x by 2 and we must divide this by quotient of x, that is 1 by 2, because we are using a formula for x for ax plus b. So we must divide by a, that is 1 by 2. First function integral of second minus integral of differentiation of first. Differentiation of x is 1 into integral of second. Integral of second is same as this. So this will be minus cotangent x by 2 divided by 1 by 2 dx. Minus integral of differentiation of first into integral of second dx. Minus, now integration of cotangent x is log sin x. So integration of this will be log sine x by 2, and we must divide by coefficient of x, that is 1 by 2. This is equal to, now 1 by 2 cancels with 1 by 2, and we get minus x cotangent x by 2. Now this is minus two into integral of this is, so this is equal to, now minus minus is plus, and this half will go 2 into cotangent of x by 2 dx minus 2 log sine x by 2, and this is equal to minus x cotangent x by 2 plus 2, and integration of cotangent is log sine x by 2 whole divided by 1 by 2 minus 2 log sine x by 2 plus constant of integration. So this is equal to minus x cotangent x by 2, and this will be 2 over 1 by 2. This will be 4 log sine x by 2 minus 2 log sine x by 2 plus c. Now these two terms add, and we get this is equal to minus x cotangent x by 2 plus 2 log sine x by 2 plus c. So this is the answer. So what we note in this question is we had 1 minus cos x in the denominator. We changed it into a single term. By doing so, we could separate this question into two simple questions whose integration is known. We changed this into a single function and then separated this into two integrals whose integration is known. You can try the following questions yourself. In this question, we will take this as first function and this as second. This is an exceptional case. So 1 will be taken as the second function. First function into 1 will be taken as a second function. And here in this question, we will use sine inverse x plus cos inverse x is equal to pi by 2. We know this standard result from inverse functions. Sine inverse x plus cos inverse x is pi by 2. So we will have pi by 2 in the denominator. This will become pi by 2, and here we will change cos into pi by 2 minus sine inverse x, and this will become 2 sine inverse x minus pi, which you can try.